So this thing is called a galvanometer. Okay, it detects small currents. And here's a coil of wire. So it's kind of like the solenoid, except that instead of it being in the shape of a tube, it's just all together. So a solenoid is this, it's like the tube shape. This is a coil of wire. It's just wrapped up the way you'd wrap up a hose or something like that. And you can see the needle here. Now watch what happens. Notice that as I'm moving the magnet, the needle is moving back and forth. The needle is moving. If I just leave the magnet in here, though, is it enough just to have the magnet in there? There's a magnetic field now in the middle of that coil. Is there any current?
I don't think so.
No, right? Zero. But as soon as I move the magnet, then there's current. Okay. And so the thing here is, if there is a changing magnetic field, that produces current. Okay. So check this out. Anytime you have something moving, if you have magnets there, right? Anytime you have something moving, you can create current from it. That's how windmills work. You get that thing spinning, that's just tons of movement. So you arrange magnets the right way in relation to coils of wire, and you generate electricity. I mean, that's really the idea behind any electrical generation. Even like a nuclear power plant, what they're doing is they're heating up water. That water is then going through turbines and spinning them. And that's creating electricity like this. Same way we're generating electricity here. Right? Obviously just on a much bigger scale. You've got a water wheel in a river or something like that. The water spins the wheel, same deal. So what's the lesson here? The lesson here is that changing magnetism creates current.